Hey there, Seahawks. It's Miss Adams, and in this video, we're going to be analyzing binomial variables. All right, the mean and the standard deviation for a binomial random variable. If a count x of successes has a binomial distribution with number of trials n and probability of success p, then the mean of x is n times p. And the standard deviation of x is the square root of n times p times 1 minus p. When we're using technology on our calculators, the TI-84s, you're going to go to second vars, which is the distribution menu. For a binomial CDF, it's going to ask you for NP and R or X, and it computes the probability that X is less than or equal to R. Note that if you need to find a greater than, like probability that x is greater than 2, you have to do 1 minus probability x is less than or equal to 2. So the calculator only does less than or equal for the binomial CDF. You could also use Staplet.com under probability, use the binomial distribution feature. All right, example, finding binomial probabilities involving several values by formula. The fingerprint for every finger can be classified into one of three basic patterns: a loop, a whorl, or an arch. Forensic experts have determined that about 65% of all fingers have loops, 30% have whorls, and 5% have arches. Suppose that these percentages are exactly correct and the pattern on one hand are independent from one finger to the next. Select a person at random and classify each fingerprint on his or her right hand. Let x equal the number of fingerprints with a loop. Victor has 2 loop patterns in his fingerprints on his right hand. Find the probability that a randomly chosen person has 2 or fewer loop patterns on his or her right hand. So x is a binomial random variable where n is 5 and p is 0.65. All right, if I want to find the probability that x is less than or equal to 2 or fewer, this is the same as the probability that x is 0 plus the probability that x is 1 plus the probability that x is 2. So if I need to find less than or equal, I could find each piece that's less than or equal individually and add them together. So I could find each one by doing a binomial PDF or using the formula with the combination. So when x is 0, it would be 5 choose 0, 0.65 to the 0 power times 0.35 to the 5th. When x is 1, it would be 5 choose 1 times 0.65 to the 1st times 0.35 to the 4th. When x is 2, it would be 5 choose 2, 0.65 to the 2nd times 0.35 to the 3rd. And we get 0.2352. Calculate and interpret the mean of x. So the mean is n times p, so it would be 5 times 0.65, which gives me 3.25. We interpret this. If many right hands are classified, we'd expect 3.25 fingerprints with a loop on average. Calculate and interpret the standard deviation. Well, the standard deviation is the square root of n times p times 1 minus p, so it would be the square root of 5 times 0.65 times 0.35, which gives us 1.067. All right, if many right hands were classified, the number of fingerprints with a loop would typically vary from the mean of 3.25 by about 1.067 fingerprints. All right, finding a binomial probabilities involving several values with technology. Sadly, a 49-year-old woman known only as patient PS suffered a brain injury that caused vision loss on her left side of her visual field. PS insisted that she couldn't see anything on her left, but scientists wondered if she might still be able to respond to some information from the blind part of her visual field by virtue of the phenomenon called blind sight. In one experiment, patient PS was shown 2 cards, each of which had a simple line drawing of a house centered on her visual midline. However, one of the houses also had flames coming out the left side. When PS was asked what she saw on the card, she answered a house. When asked if the house were the same or different, she replied the same. When she When asked if there was anything wrong with the house, she replied, no. The researchers then shuffled the cards, placed them on the table, and asked PS which house she would rather live in. This exercise was repeated 17 times. If PS truly could not see the house with flames on the left, then her card choice would be random. Let X equal the number of times someone would choose the non-burning house by random chance alone. Compute the probability that X is greater than or equal to 14 with technology. So the probability that X is greater than or equal to 14, we can't do greater than or equal using the calculator, so I'm going to have to do 1 minus the probability X is less than or equal to 13. This is a binomial setting where n is 17 and the probability is 0.5. So 17 because they repeated it 17 times. There's 17 trials. And either the house was burning or not burning, so 50%. So this would be 1 minus a binomial CDF where n is 17, p is 0.05, x is 13. So 1 minus 0.9936 gives a 0.0064. Based on the fact that PS chose the non-burning house 14 times out of 17, and on your answer to part A, are you convinced that PS had some sort of blind sight, even though she insisted she couldn't see anything on her left? Explain your reasoning. So, patient PS had less than a 1% chance of choosing the non-burning house 14 or more times by guessing. Because that is unlikely to happen by chance alone, there is convincing evidence that the patient PS has blind sight. All right, go Seahawks.